Okay, this is part 2 of our triangle midsegment theorem video. And in this part, I'm going to prove that MN is exactly half the length of AC, as that is the second half of the triangle midsegment theorem's claim. So in order to do that, instead of relying on the slope formula like that last time, this time we'll be relying on the distance formula. And we're going to use the midpoints that we found in part 1, plug those into the distance formula to find the length of line MN, and then we're going to use the given points here, plug those into the distance formula, and see if we can show that one is half the length of the other. Okay, so here we go. Let's turn this down so we can still see it a little bit. And here we are. So M and N, the location of those 2 points is found with the midpoint formula, just like in the last video. And we're going to come back to those and use those in a minute. But let's start with the easy part. The distance between A and C would be x2 minus x1. So there's my x2, there's my x1. So here I'm going to have the square root of C minus A squared plus, oops, that's the wrong part. So for AC, I'm going to have C minus A squared plus y2 minus y1, which will be L minus H squared. So that's the distance, or the length of AC, the distance between points A and C. Now for the much more intimidating part, let's find the distance between M and N. This time, my y2 is this value, and my y1 is this value, and x2 is this one, y2 is this one. So we're going to plug it into the formula and see what we get. X2 minus x1 squared plus y2. Let's see, I'm going to have to hide these. y2 minus y1 squared. Okay, now I'm going to do some simplifying inside of here, and if you have trouble following the simplification, you're going to have to go watch the previous video, because otherwise I'm going to run out of space. Essentially, b halves is going to cancel with negative b halves, and then k halves is going to cancel with negative k halves, leaving us with a slightly simpler c minus a over 2 squared plus L minus H over 2 squared. So we're looking pretty good. We've got C minus A, L minus H, C minus A, L minus H, and the divisions by 2 here. So if we can just get it the rest of the way, and here's sort of the sneaky little trick that you probably wouldn't see without somebody showing you. This squared is operating on the C minus A and the 2, and the L minus H and the 2 independently. So we can simplify like this. We can say C minus A squared over 4, because 2 squared is 4, plus L minus H squared over 4. So we just sort of separated out, squared the top and squared the bottom. And now I can factor out that 1/4, which gives me 1/4 times C minus A squared plus L minus H squared. And then the square root of 1/4 is 1/2. So this will simplify to 1/2 times the square root of C minus A squared plus L minus H squared. And now notice c minus a squared plus l minus h squared is the exact same length we have for AC. But we also have this 1/2 that we've factored out and simplified out of here through algebra magic. So there it is. That is the algebra intensive proof that the length of MN, the triangle midsegment, is exactly half the length of the side to which it's parallel.